Alright, welcome back. So we continue on. We were looking at question 2b, thinking about C, thinking about how we could understand the manipulation of these. Alright, we can do U substitutions on each of these, but I'm trying to train you intuitively and just get some recognition of some basic ideas. And so you can use your manipulation of the rules, which is what mathematicians and statisticians do. So we put the 11 across the front. So it will be 11 lots of the integral 2x minus 3 and ask the question, is the derivative of the denominator on the numerator? And the answer is no. So we introduce a 2. So the bottom half of the 2 will sit here because this is the 1. And the top half of the 2 will sit on the numerator. So there's our 1 in disguise. Okay, there's our, don't need to do this really, 1 in disguise. We introduce this thing times by 1. In the form of the 1 was 2 over 2. And if we ask the question, is the derivative? Yes, it is. So now we can just go straight for 11 over 2. The ln of the denominator, 2x minus 3 plus c. Okay, so we're able to do these fairly readily, and hopefully what's happening is you're doing it as well. Alright, so B, what are we looking at? Oh, some trig, awesome. Is the derivative of the denominator on the numerator. Well, you just got to be a little bit careful. It's close. The derivative of sine is cos, so the derivative of cos is minus sine. So we would need to multiply this by a form of 1 where we have minus minus. Okay, so the minus 1 at the top would cause us to have minus sign, and we'll get a minus out the front. So these are a little bit tricky. I'll be very careful. If you did the U substitution, you'd be doing the same thing. So you're going to have minus the integral, minus sign, over cos x plus 2. Now, is the derivative of the denominator on the numerator? The answer is yes. So we've created this minus, which we need to, came about because of the derivatives. So we've got minus the ln of the denominator. So there you go. Very straightforward. I have to get your capital C because if we differentiate this, we will get this original quotient. Wow. We'd have to use a U substitution. So you've got lots of practice for your U substitution, for your chain rule. So d dx. It's up to you. That's your study now. You can use Wolfie to help you. That's great practice, okay? But you've got to sit down and do the work if you want to confirm yourself, okay? Alright, so now this one's going to be a bit trickier, I think. So I'm going to draw a bit of a line across here. Probably take a little bit of time with this one. Because for f, we've got a derivative that involves the chain rule. The cos of 2x over the sine of 2x. So when you come to ask this, you can do this as a chain rule, if a U substitution, if you want to. Okay, you can do this as a U substitution if you want to. Or you can recognise that the differential of sine is in fact cos, so it's very close, But the differential of sine 2x is a chain rule. So if we were to d dx, let's just check this. If we were to d dx, the denominator, based on what we know of expression chain rule, okay, we would let u, now this is differentiation, not in your column, 2x, and we would then rewrite, making sense of that would be, see the difference? In the column you don't do this. Sine u, we're rewriting it. Okay, so we've got du dx, and the d du and the du dx form a chain. So we're going to put together the outputs of these. So the differential of sine is cos, and the differential of 2x is 2. So the full d dx is equal to 2 cos. This is where a student can make a mistake, because cos 2x is closed, but it's not there. Okay, the d dx of sine 2x. So what's missing? The 2. So we need a 2 up here. Okay, so the way that we implement the 2 is we do it in our mind's eye. That's what we need. So I'm really taking shortcuts now, aren't I? So based on that, I can say, is the derivative of the denominator on this new integral equivalent? Yes, it is, because the differential of sine 2x is 2 cos 2x. So it is there, but we've got a half. So if we do the integral, I can do a half, learn the denominator. So you could do u substitution. The u substitution would have in it a chain rule, which is always a good thing in my book. Okay, and that's our plus c. Okay, so that's the one that we've got there. Wow. Okay, we could do the u substitution, and in fact I might redo f as a u substitution just for a bit of fun, because we can. Alright, just because we can. So what would we do? We would let the bottom, let u sine. You know we're going to have the same issue. We're going to have to differentiate the u dx staying in the column. Okay, so the problem that we've got is that this is a chain rule. So this requires us to assign a new variable. Let m equal 2x, just like I did up the top. So now I can rewrite u, because it's differentiation chain rule, sine, even though we're kind of staying on, m, okay, and then I've got du m, and I've got the m dx. So we are going to have the chain rule here, du dm. And I really feel like I'm justified in doing this, because this is actually the gold. This is what I want you to be able to do. I'm really happy if you can do this up here, the way I've done it, just using expressions and the recognition idea and putting that together. I'm really pleased if you can do that, but the truth of the matter is the horsepower for Maths 1 is in this. Okay, it's the same thing, it's an equivalent approach. So the differential of sine is cos, that will be m, and the differential of 2x is 2. So the chain goes together, and that means we've got 2 cos 2x. And then we ask the question, so we've got dm dx. So let's bring that down, because we're in the column. du dx just discovered is 2 cos, and I've kind of deliberately kept the integral away, keep you thinking. After a bit of manipulation, we can write du is equal to, and we've had a conversation about next steps. So let's just have a look, see what we can see. Here's our dx. So our integral was cos 2x over sine 2x plus 1 dx. So we can ask the question, are you there? Yes. Are you there? Well, the 2's not there. The cos 2x, okay. So this is decision time again. We divided by the x, didn't we, and get some algebra. Now we've got to divide by 2. So we're going to divide by 2, and that means we'll get 1/2 du is equal to cos 2x. So it's the same outcome, regardless of how you visualize and become intuitive with it. And you now got to ask that question, are you there? Yep. There I am. Are you there? Yep. There I am. So you're both gone. And you're gone by du half the integral. That's the u substitution. Stay in your column. That's the u substitution. Look at all the work that's there. For me, that's just as valuable as anything we do in this subject. Okay? So being able to pull all that apart and assemble it that way. The other method was okay. It was intuitive, but you had to really have your recognition glasses on. Here, this is a skill set using a chain rule, which is why I'm doing it, because the chain rule is needed in your U-subs. Okay, so you'll be doing that in Maths 1, and you'll be doing that in Maths 2. So this is great practice, the chain rule in your U-subs. So what we end up with at the end of the day is 1 over u. 1 over u. And then we're going to ask that, because that's the trivial substitution. Okay, cos 2x is gone and there's a 1. Sine 2x plus 1 was our u, so we've rewritten this as the trivial 1 over u. So we did all the hard yards on the right column to give us 1/2 du, and then the 1 over u was the trivial one. So if we do the integral, is the derivative, we can ask that question, is the derivative of the denominator on the numerator? Yes, it is. So this now lends itself to this replacement, a further replacement of using ln. Okay, and the denominator is u, so I'll just do that for the sake of completeness. And of course, the last thing we want to do is put into the u, okay, inside there. So u itself was sine 2x plus 1, and that's the final result. Sine 2x plus 1, don't forget your capital C. So that's your result. Now look, they're the same. They're the same, see that? They just came about in a slightly different way. My advocacy for you is that you make sure you understand how to do U-subs with a chain rule. Okay, I'm absolutely saying that that's a necessary thing for foundation maths. For people who pass and leave foundation maths, you must have U-substitution with a chain rule, and going into Maths 1 and Maths 2 you will encounter that in both of those subjects. There's the kind of shortcutty idea where we said what's missing, because we intuitively did the chain rule just as an expression and recognised that we needed to have a 2 cos 2x. So I put it in as a 1, which is what we've been doing above, and there was a half out the front. So we got the same result as if we did the U substitution. It's not nothing. I'm accepting that. I'm accepting that it's not nothing. Okay? Now this notion of the derivatives with a chain rule persists. Okay? And we've got the same thing here with G. With G, we're being asked to recognise what the derivative is And the derivative is a chain rule, so you can come at this either way. Is the derivative of the denominator on the numerator? And the short answer is no. It looks like it could be, but it needs to be checked. And so we need to check the denominator. So we're going to do a check. We're going to d dx, e to the 2x plus 7, and we're going to find out what that is. Now, it turns out that the plus 7 will disappear because it's a constant, but the e to the 2x is problematic. So we need to let u equal, now this is not a u substitution integration, this is a differential. We're just checking the differential of the denominator. Let u equal e to the 2x. That's not right. We want to have, dear, we can't do dm dx because we need to now let m equal 2x. So this u can now be rewritten as u is equal to e to the power m. Okay, so we can do our du dm, and the other part of the chain is dm dx. So they'll chain together and we'll get a result up here. So the differential dm dx is 2, easy peasy. This is the one we love, e to the m. So putting those together in our chain, we will get 2e to the m, and m itself was okay. So the differential is actually 2e to the 2x. So we have to multiply this by 1, not to change it, and the 1 that we'll change it by is 2 over 2. Is the differential of the denominator now on the numerator? Yes, it is. So we can go ahead and make the substitution directly. The ln of e to the 2x plus 7. So we're being quite cheeky. So the people who are always telling me to hurry up will be happy because they can chop off on to the next question now. But guess what I'm going to do? I'm going to do this question again as a genuine u substitution, simply because I can. Okay, so you can scrub past this if you don't want to do this. So what I would do here is I would let u be the denominator, and I would stay in the column. Okay, now I'm doing u sub. Up the top there, all I did was a check of the derivative of the denominator. Now I'm doing an actual u sub. And the problem is I can't do du dx for the same reason. So I've got to let m equal 2 to the x plus 7. So it's a further substitution. And over here I can now write u equals e to the m. Feels like I'm doing a similar thing, doesn't it? Du dm. Chain together with dm dx, which is just multiplication. So I can do those. E to the m is e to the m. Wonderful. M dx, dm dx is 2. So I chain them together. Okay. And du dx, which is this bit, du, and this is where a u substitution, staying in the column, is equal to 2 m was e to the 2x plus 7. Okay, let's go and check it. Now I deliberately left the integral away because I wanted you to think carefully about this. Okay, so I'll write the integral again. It's the same integral. Getting you to think about what's happened. Oh, now the plus 7 is out, so that's my mistake. check myself sometimes. Okay, I need to check myself sometimes. I did the differential correctly, but plus 7 is down here. So plus is just 2 to the x, and e to the m plus 7. Differential of that will just be e to the m. Differential of 2x is 2, so we get 2e to the 2x, nothing's changed there. So we're looking to see now if we've got, it's easy, isn't it? It's easy to both things. Alright, so let's just manipulate dx. So we're going to multiply both sides by dx. U will be equal to 2e to the 2x dx. Okay, are you there? Yep. Are you there? No. The 2 is not there. So we need to divide by 2. We need to go another step. Okay? So we need to move the 2 over to the other side. Now we've got 1/2 du is equal to e to the 2x. Now we can ask the question, are you there? And the answer, of course, is yep. Are you there? Yep, there I am. Okay, I'm over here. So you're both gone, and you're substituted out by du. The half will come out the front because that was the substitution for the column. Stay in the column. Okay, so that was stay in the column, and we've done the substantive substitution. Now 1 is on the top of this is the simple, trivial one, and it's 1 over u. And so we end up asking the question, is the derivative of the denominator over the numerator? And the answer is yes. So we can now go straight to the integration, which is 1/2 the ln of the denominator plus c. Now that's not complete, so we need to do 1/2 ln of the original denominator e to the 2x plus 7 plus capital C. That's our final answer. And that's the same as the other one. There it is there. 1/2 ln e to the 2x. Leave it up there, that was naughty. Didn't draw that properly. That should be plus 7. Okay. No, that's fine. So it's just that last bit. Alright, but they're the same. So we've managed to conquer what I believe is the primary skill in this particular subject. Okay? Alright, so coming up to 23 minutes, I might just finish off H, because I don't think H is terribly difficult. One level is the, now we can't do the is the rule, and this is a good reason for doing this question now, because we have no choice. We have to deal with that idea that is the denominator the derivative of the denominator on the numerator? No way, not even 2x because of the 3. So we've got no choice. We must do a u sub. Okay, we've got no choice. We'll get to do the ln question a bit later on, I suspect, but we need to do a u sub. So we're going to stay in the column of x squared plus 9. We're going to do our Leibniz notation and do the substitution 2x. So we're going to multiply by dx, and we will pull the half down, divide by 2. So we do all of that, and we get 1/2 du is equal to x dx. And then we ask those questions, are you there? Yes. Are you there? Yes. So you both subbed out, and you subbed out by this substantive substitution. Okay, what's left is a 1 trivial. Now we can do the trivial one, u3. Okay, now well, there's two ways to do this. We could bring the u up, okay, and do u to the -3 and up and under, Or we can think to ourselves, is the derivative, and it's not there. So we'll do an up and under. So that's what we'll need to do. So we'll rewrite this again. So we'll go u to the minus 3, u, and we'll do up and under on that. So minus 3 plus 1 is minus 2, divided by minus 2 means that we've already got a half out the front. So we're going to have a 1 half divided by 2. And so it's going to be on the bottom, divided by 2 plus c. So we're going to end up with minus 1/4 u to the minus 1 plus c, which is minus 1/4 1 over u, which is x squared plus 9. Now, what have I put here? That's a 2. It's a 2. 3 plus 1 is 2. So it's going to be x squared plus 9. So we had no choice. We had to make our u substitution squared plus c. This would be x squared plus 9. So it's the same thing there. So we've got a result. Now you can put the 1 and 4 together. Alright, or you can leave it in this form up here. Okay, you can leave it in this form if you want to, depending on the question and how it's summed. So just think about that. Alright, so we'll leave it there. That's a good video. Lots of meat in that one. So I will see you next time.